On September 19th, 2021, the first eruption of the La Palma volcano in the Canary Islands in 50 years began. Since this eruption has just entered its 6th day, we have been able to calculate the total volume of erupted material so far and the rate of erupted rock. Since the eruption began, 26 million cubic meters of rock has been output at an average rate of 57.8 cubic meters per second. Although this may not sound like much, that is a pretty significant volume of material. For comparison, the ongoing Gildingadalur eruption adjacent to the capital Reykjavik in Iceland has been erupting with a volume of approximately 1/6 this amount. The total volume of erupted lava blows past the original estimate of underground magma, meaning that at least for now, the mantle is supplying a consistent volume of material to the erupting vents. Additionally, this is about 60% of the total volume erupted during the much longer 1971 eruption. This means that the ongoing eruption could last for several more months, although it is difficult to predict exactly how long due to the daily fluctuations in activity. The ongoing Strombolian-style eruption has alternated between towering lava fountains and large volcanic explosions which have ejected bombs of lava in a more than 1,000-meter radius. The most energetic of these explosions were significant enough to create a large shockwave which could be easily seen and heard. Just listen to the sound, which was energetic enough to break windows up to 3 kilometers away from its source. This explosion was incorrectly attributed by some to be a Vulcanian-style explosion, suggesting an eruption an order of magnitude larger than what is going on so far. However, this is not the case. Vulcanian-style eruptions involve pyroclastic flows, and no such density currents have been confirmed during the ongoing eruption. So far, the possibility of a tsunami occurring remains essentially at zero. Many people have asked me how I make such an assumption and what hypothetical warning signs could exist if a landslide-caused tsunami was to occur. Although volcano-caused tsunamis are tough to predict, they generally occur due to the same reason. Magma doesn't just need to be in the volcano, but it needs to be pulling right underneath the slope of the volcano. Thus, as the magma builds, it pushes the overlying ground upwards, causing ground deformation. If this was to occur on the order of tens of meters, then it would be an early warning sign. An extreme example of this occurred in 1980 at the Mount St. Helens volcano in the United States. In the days leading up to the partial collapse of this volcano, the ground bulged upwards by an impressive 80 meters or 260 feet in a span of only a few weeks. Since the ongoing eruption has only uplifted the ground by a maximum of 30 centimeters, there is no danger of a tsunami. Although the output of lava has remained relatively constant during the first 6 days of the eruption, the advancing lava flows have not. Instead of continuing downhill at a uniform rate, they have largely slowed. At one point, they were advancing towards the ocean at 700 meters per hour. This later decreased to 200 meters per hour and is now a mere 4 meters per hour. Since the lava is largely piling up instead of continuing onwards, it is not a certainty that it will reach the ocean. Although lavas did reach the ocean in the majority of recent eruptions, it did not during its 1480 eruption. I personally expect this lava flow to indeed reach the ocean, thus causing a series of large explosions and eventually building a fan-shaped platform of lava, much like what occurred during the 1949 eruption. As of the writing of this video, the number of structures confirmed as destroyed has increased from 320 to 350, while the extent covered by the lava flows has increased to 1.66 square kilometers. Thanks for watching.